Section 2.3 talks about measures of the location of the data. And location may seem like kind of a funny term, but it's location in the data relative to all the other data points. So the two most common measures that we'll use for location are quartiles and percentiles. Percentiles may be familiar to you if you've ever looked closely at your scores on Terra Nova tests or the PSAT or anything like that. Quite often your score will be given to you as some kind of numerical score, but then also you'll get a percentile rank, and that will kind of tell you where you did relative to other people who took the test. Quartiles, we're going to start with quartiles, I think. Quartiles divide the data into quarters, okay, or into fourths. So percentiles divide data into hundredths, right? A percent, 1% is 1/100th of something, so percentiles are hundredths. And anytime we're going to calculate either one of these two values, it's always best if we have the data ordered from least to greatest. So if we don't have it given to us that way, we'll want to typically use some technology to try to get it in that order. Percentiles are, like I said, fairly common if you've taken any kind of standardized testing, but they're really useful for comparing values. And to kind of give you an idea of what it really means, if say you took the SAT and your score was the 90th percentile score, it means you did as well or better than 90% of the people who took that test. Doesn't mean you got a 90%, right? You didn't get it 90% right. It means you did better than 90% of the people who took it. Percentiles are often really useful when your data gets really large, okay? Something like the SAT, for example. You know, there's hundreds of thousands of students taking the SAT all on the same day. That's a pretty large data set. Percentiles are pretty useful there. The median is one particular value that's special that we pay attention to. It is the value that is in the middle of the data, kind of like the median is that thing that divides the northbound and southbound lanes of the interstate. The median is in the middle of those lanes. Well, the median is also in the middle of the data. So note that if you have an even number of data points, like if you have, let's just keep it easy, if you have 10 data values, then your median would actually be the average of the two middle points, so like the 5th and 6th points. You just take those two values and find the average of those two. So sometimes the median is not actually in the data itself. Sometimes it's between two data values. Just as a connection point, the median is also known as the 50th percentile value. All right, so here we just want to basically practice finding the median. And one of the things you probably want to do first is count, see how many we have. And it looks like we have an even number of points. And so the two numbers that are in the middle are this 4 and 5. All right, so like I said, sometimes when you have an even number, you're going to get a median that's actually between two values. So we need to take 4 and 5 and find their average. Well, the average of 4 and 5 is 4.5. There's our median. Quartiles are, like I said, dividing the data into fourths. And in some cases, we may have quartiles that are not actually part of the data, kind of similar to the way we just discussed with the median. So basically, to find quartiles, the way we're going to do it is either in a calculator, which I'll show you in a minute, or we find the median first, which is technically the Q2, the second quartile, and that will divide the data into a lower half and an upper half. Okay, so we take the lower half of the data and find the median of that. That'll give us the Q1, the first quartile, or sometimes called the lower quartile. And then we take that second upper half of the data and we find the median of that, and that finds us the Q3, which is the third quartile, or sometimes called the upper quartile. So here's the same set of data we had a minute ago. We want to find the quartiles. Well, we already know that the median is 4.5, right? We found that a minute ago. And what that 4.5 value does is it splits the data into two chunks, the lower half and the upper half. Okay, so just looking at the lower half for now, the 0 through 4. What we want to try to do is just work our way out work our way in from the outside. So if you kind of take the 0 and the last 4 there and you cross them out and then work in, we have a 1 and a 4, cross those out, then we have a 1 and a 3, cross those out, and that middle value is 2. Okay, so our first quartile or lower quartile is 2. And then on the upper half, we do the same thing, the 5 and the 8, the 5 and the 7, the 6 and the 7, and it leaves us in the middle with a 7. So our third quartile or upper quartile is 7. All right, so with small data sets, with relatively simple sets of data, finding the median and the quartiles is pretty easy to do by hand. The interquartile range. When we're looking at a set of data, there are times when we want to be able to maybe take unusual values and decide what to do with them. Sometimes we may discard them. We go, these are weird values, we're not going to consider those. Or maybe those weird values may cause us to make a different decision. It'll kind of depend on context, but that determination is really down to determining if an unusual value is what we call an outlier. And the criteria that we use for determining potential outliers is with this interquartile range. So basically, to find this, you subtract the Q3 minus the Q1, or third quartile minus first quartile. Okay, and what that does is it gives you a range of values for the middle 50% of the data. Okay, the Q1 separates the bottom 25%, the Q3 separates the upper 25%, so that leaves us with the 50% in the middle. And what we'll do is, to find an outlier, is multiply this interquartile range by 1.5, and then we'll look to see if any values are 1.5 times less than Q1, 1.5 times the IQR, less than Q1, or 1.5 times the IQR higher than Q3. Okay, if we see a value that exceeds those boundaries, then we consider that to be a potential outlier, and then we'll make a decision about what to do about that potential outlier in the future. So I mentioned this a second ago, 1.5 times the IQR, below Q1 or above Q3. All right, so here's an example where we can work on the IQR. This set is got some pretty big numbers in it, and it's just big enough and complicated enough that it's probably going to be helpful to use some technology. So we're going to go to Google Sheets and look at this data there. All right, so we're going to look at trying to figure out the IQR for this set of data. All I've done so far is copied the data values from the slide to this Google Sheet. So the first thing that we're going to do is we're going to sort this data so that it's going from least to greatest. And if you don't know how to do that in Google Sheets, you highlight the data that you want to sort, right-click, and then sort range. And then it's pretty smart. It usually figures out exactly what you're trying to do. We're going to sort by column. That's the column A, the data where the data is. A to Z means from lowest to highest. And then we sort, and there we have it. So now we can see that our data is all in order from least to greatest. So similarly to the way we found the median and the Q1 and the Q3, we're gonna do that again. So notice that we have 13 values. So right in the middle is going to be this value here in the 7th row. So this is our median. So what that does then is it takes these 6 values. Let me just give that a little color there. And these 6 values, give it a little different color there. Those, this is our lower half and this is our upper half. We want to try to find the middle of these two sets. Notice that I did not include the median in creating these sets. I want to use all the numbers that are less than the median and then all the numbers that are higher than median, but not including the median itself when I'm trying to find the Q1 and the Q3. So right halfway in between these two numbers is going to be our Q1. So we can let the calculator, let Google Sheets figure this out for us. We'll take the first number, 230,500, and add the next number, 387,800. 0, 0, 0. Take that, divide it by 2. Basically, we're just finding the average of those two numbers, and that's 308, 750. So this is going to be Q1. Label it over here. All right, so now we do the same thing down here. We have 639,000 and 659,000. It's a little easier to figure out. I think that answer is going to be 649,000. But if you don't trust my numbers, let's just try it. 639 plus 659 divided by 2. Look at that, 649. Okay, so that's our upper quartile. That's Q3. So the inner quartile range, okay, the IQR, is just the difference between the upper quartile and the lower quartile. So we'll just take this minus this one. We hit enter. So our IQR is 340,250. Okay, there's our answer right there. I also wanted to mention that the interquartile range, the real purpose of it is to help us to identify outliers, potential outliers, I should say potential outliers in our data. And the way we do that is we take the interquartile range and we multiply it by 1.5. So we get 1.5 times the interquartile range. So I'll do that here. Equals 1.5 times, and then I'll just select that cell. All right, so 1.5 times the IQR is 510,375. And then what I can do is I can find a cutoff point, basically, where we can say any number less than Q1 minus this 510,000 number, anything less than that would be an outlier. And then we can take Q3 plus that 510,000 number, and anything higher than that would anything in those two ranges would be potential outliers. So for example, if we take our Q1, which is 308,750, and we subtract this here, we get a negative value, negative 201,000. So obviously there are no values in our list that are less than negative 201,000, right? Our lowest number is positive. So we don't have to worry about any low outliers. But take Q3 and add this 510,000 number, and we get 1,159,375, which means that all of these values are fine except this one, right? This one's 5,500,000. So that number is what we would flag as a potential outlier. So whether or not it actually is an outlier will kind of depend on the context and some other factors. But finding the kth percentile, when it comes to finding percentiles, we have a formula that we're going to use. Basically, what'll happen is you'll be asked a question like, find the 40th percentile value for this data set. Okay, the 40%, the 40 in particular becomes the K. And then I is what we call an index for the data value. So basically it's, if you have your data listed from lowest to highest, then the index number for a value is its place in line. Okay, so if you have an index of 1, that's the first data value. If you have an index of 10, that's the 10th data value. All right, so basically what this formula is doing is it's pointing you to the correct value in the list. If, when you plug in this formula, you get an integer for I, you get a whole number, then you use it. Okay, the number in the ith position is the percentile you're looking for. If you get a number that's not an integer, then what you'll do is you'll take, like say for example it was, say you got 11.3. All right, then what you do is you take the 11th value in the list and you take the 12th value in the list and you average those two together. Okay. Even though 11.3 is not exactly halfway between 11 and 12, that's our procedure regardless of what the actual numbers are. Okay, so here is a list of data. We're going to go to Google Sheets again to look for the 70th percentile and the 83rd percentile for these data values. All right, so for our percentile example, what we have here are 29 data values, which we can't quite see all at one time. I have to scroll, but 29 data values that represent the ages of actors, Oscar winners, I think it was. And so we want to find the 70th percentile value and the 83rd percentile value. So remember that our formula is the percentile, the K, which in this case is 70, divided by 100, times N, which is the number of items in the sample, plus 1. So again, there's 29 in this list, so 29 plus 1 is obviously 30, but just for the sake of, there we go, letting the computer do the work, we get 21. So this number is not the percentile value, it's the index where we will find the correct value. So we need to go to the 21st row, and so this value in row 21 is our percentile. The 70th percentile is 64. Okay, so this is our answer right there. Same thing for the 83rd percentile, so equals 83 divided by 100 times, again, 29 plus 1, or this time I'll just put 30, and that gives us 24.9. So obviously 24.9 is not a whole number, so we're going to look at row 24 and row 25 and average those together. So 83rd percentile is 71.5. So it's not actually a data value, right? Which may seem kind of odd. Strange that it's not an actual value in the list. It's in fact between two numbers, but what that does is it guarantees that we're at least greater than 83% of the data values. So that's how you find percentiles using that little formula. So hope that helps. All right, now perhaps we want to work the other direction. Okay, sorry about that. That was my phone. Perhaps we want to work. Okay, sorry. Okay, perhaps we want to work the other direction. Say instead of being asked to find the 40th percentile value, maybe we have a list of data and we pull one value out of there and we go, all right, what is the percentile for this value? So we're working kind of in the opposite direction. And in order to do that, we change our formula around where X is going to be the number of values that is lower than the number that we're talking about, and Y is the number of values that are equal to the value that we're talking about. So in some of the lists we've used so far, we've had some repeating values. So what you do is for X, it'd be anything less than your number, and Y would be the number of times that your number shows up. Okay, N is going to be the total number of values, and we'll plug it into this formula here. Okay, so when it comes to interpreting percentiles, quartiles, and median, you need to understand that there's some things are always true. Okay, low percentile values are going to mean lower data values. Higher percentiles are going to mean higher data values. Right? Whether or not you're high or bad, high or low is good or bad will depend on the context of the data. Okay, don't automatically assume that a higher percentile is always better. If you're talking about golf scores, you don't want the higher percentile. Our suggested homework for section 3 is these problems out of the practice section. Basically just giving you the chance to find some quartiles, find some percentiles, and hopefully that'll be helpful to you. Section 2.4 is about box plots, and it fits in well with our discussion of section 2.3 because the values that we found in 2.3 show up on the box plot. So sometimes you may have heard of this as a box and whisker plot, but basically what this does is we draw a box that represents the IQR. So we see that we have a box in the middle, and then we have lines sticking out of the box to the left and to the right. So the box represents the range of values from Q1 to Q3. Okay, the dotted line that you see inside the box, that's the median, and then the ends of those two whiskers, the lines that stick out of the box, on the left is the minimum, and on the right is the maximum. Okay, So here is a set of 40 data values, and we're going to switch over to looking at the TI-83, and I want to show you how you can create box plots in the calculator.
All right, real quickly I want to show you guys how to create a box plot in the calculator. So first thing you're going to need to do is put your data into your stat lists. So we're going to hit that stat button. It brings up this menu here. And we just want to press enter on edit. And as you can see, I've already put this data into L1. So you want all 40 values in this first column here. I know I'm going too fast for you to actually keep up, but all the data is in the slide, so you should be able to get it there. All right, so that's all 40 values. And then I quit by hitting second and then mode. And that takes you back to the home screen. And then what we want to do is we want to create a box plot. So we hit second and then y equals, and that brings up the stat plots menu. And I've already turned this one on just to take a look at it in advance, but you'll hit enter on this first plot. Yours may be off currently. It may be over here, so you want to go to on and hit enter to turn it on. And then you want to select the fifth option there. Okay, it should look like a, may not be able to tell on the video, but it should look like a box and whisker plot, box plot. So select that one. It should automatically have L1 listed there. But then what I would recommend you do is hit zoom. Oops. All right, let's get out of there. Zoom. If you get that weird menu, just quit and then hit zoom. And we want to go down to number 9, which is zoom stat. So any stat plots that we have turned on, the graph window will automatically zoom to that picture. So now the nice thing is if you hit the trace button, you can see each of these 5 important values. So the median is right there in the middle of the, well, not in the center, but it's inside the box. The Q1 is 64.5 on the left edge of the box. The minimum is 59. And then if we come back over, the Q3 is 70 and the max is 77. Okay, so that's how you go about creating a box and whisker plot using your calculator.
Our suggested homework for section 4 is just 2 problems. It's actually not drawing box plots in these problems, but interpreting them, looking at them, and answering some questions. So I think doing it that way will help you better understand what's going on in the box plot, because drawing them is not hard at all, but interpreting them a little more challenging, and I want to make sure everybody understands how that works. So good luck on this, and let me know if you have any questions.